Hi folks, Chuck Black here. We're doing 52 weeks of Python. In this particular lesson, I'm going to be talking in more detail about printing. We've done a little printing up to this point, but I'm going to go into it in a little bit more detail when we get into the teaching and the learning about Python portion of this. But before we begin, I wanted to introduce you to a couple of things that I've added to this Quokka thing that I'm developing side by side with the class that I'm creating. I've created functionality to do capturing of packets on the network for either devices or hosts or services. And I've also added the ability to do a port scan or a host and port scan on particular hosts in the network. So I'm going to talk about that. That's what's in store for this lesson. So without further ado, let's get started. Hi folks, Chuck Black here. We're doing 52 weeks of Python, and this particular week we are going to look at printing. You can see here that I've got some code that will do various printing tasks, so we're going to go over that. Before we do that though, I wanted to tease you with a little bit of stuff that I've been working on this Quokka thing. As you recall, Quokka goes out and monitors devices, their CPU and memory utilization, response time, also compliance to software version and configurations. It also discovers hosts in the network and monitors their response time as well as availability. That's the status over there. And it does the same thing for services. So we go out and we're doing just right now DNS, HTTP or HTTPS, and NTP. So I've got a few of those going, again, availability and response time. But I did add a couple of things recently, and you may have gotten a clue via what you see over here, these little icons, action buttons, as well as what you see in the top right, something called Capture. I've actually done two things, and I'm going to describe it on this host screen so you can look at these actions. Now, this button has always existed for quite a while. This shows you the response time and availability for that particular host. And then it also has an hourly summary. And you can see I've rebuilt the database so I don't have a ton of hourly summarized data, but I do have the minute by minute response time that we've got. But that's not the only button that's available now. And I apologize for these really small fonts on the mouse over. Like I say, I'm a networking guy and I'm really a back-end developer, software developer my entire life rather than a UI developer. And so I haven't figured out how to make the words that you see on this tooltip a little bit bigger, but I'll explain to you what it is. This one right here, this magnifying glass in the black rectangle, is capture packets, and it will capture packets for the host. And if we go to devices, I'm going to be capturing packets for a device. And if I go to services, I'm not going to be capturing packets based on an IP address, but rather just for that particular service. I could attempt to capture packets for the service and the IP address if I knew it, but if I'm doing something like HTTP to BBC, I don't really know the IP address that it will be going to. There may be many different IP addresses that could be returned from DNS when I go to communicate with BBC or TLAC or Google or wherever it might be. Consequently, I'm just doing the service. That's packet capture. So if I was to go, let's stick with a service right now. DNS is kind of interesting. Let me click on this button here, and it will take you to this capture screen. And you can see that I've already done DNS packet captures. This is all the DNS requests. You can see source and destination is port 53. I interpret DNS to be port 53. And if we go and examine a little bit closer, then we can see, oh, well, look at the inside. This is the actual packet information that I've gotten from doing that packet request, that packet capture. And here's all of the nice formatted DNS information, DNS question record, resource record, etc., UDP information. And this is the raw hex. Now, if you've seen Wireshark in the old days, we used to have something called a sniffer, and you could click over here and it would highlight the thing over here in the actual hex dump. So this is not a very deep implementation with tons of functionality, but it does have some functionality. As you just noticed, that wasn't very smart, that when it refreshed the screen, it got rid of this. As I say, I'm just implementing this to show you guys kind of what's going on. Now, let me tell you a little bit about how I had to implement this. So in order to implement this, I needed to have a separate process running that would be doing packet captures. And the reason for that is this. I need to run this packet capture. I'm using Scapy for this purpose, and I needed to run it separately from the Quokka application because you really don't want your web-based application running in privilege mode, because as you know, in privilege mode, you can do just about anything to the system. And if there was an issue related to some attack that took place through our web service into Quokka, then it might compromise things. So what I do is I send a message from our Quokka backend when I get a request to do a packet capture. And what I do is I send a message to this particular process that's running, and it actually goes out and then begins to do a capture. So what I'm going to do just to demonstrate that to you right now is we can look at, this is actually looking at protocol DNS, and you can see if I look at the timestamp, that is at 9:26, and if you look, where can you look? We don't actually have it showing because I have it maximized. It's on my other screen. It's actually 11:30. So when I start a capture, we should see new packets come in because it's listing them, as you can see by this arrow, the most recent first. So what I'm going to do is I'm going to start a capture. Now, it's going to attempt to capture DNS packets. And if you were quick, you will have noticed, well, there we go. We've seen a whole bunch of packets come in. I didn't have a chance to show that to you. We've got a number of packets, and it's actually going to be retrieving or listening for packets for, I can't remember now, either 3 or 5 minutes. I just set it up arbitrarily to a particular number. As I say, this is an implementation of stuff to demonstrate to you how to write software rather than attempting to be a real life product. If it was a real life product, I might have input fields that will allow you to say, okay, I want to do a capture for 2 or 3 minutes or whatever. So we've just refreshed here. And if this worked, yeah, you can see I have a bunch of packets. This is for 11:29. If I scroll down, I should be able to get far enough. Okay, now we're back in the 9 o'clock, 9:56 time frame. So I'm going to go back to the very start, and you can see that I have 11:29 is the highest. You may have seen this going on in the background. I've been getting more packets, so I'm going to say refresh that, and sure enough, we can see I've gotten new DNS packets. And of all the packet captures that I do, I think DNS is the most interesting because the Scapy does provide this output, which is really nice, a very detailed analysis of the DNS requests here that you can see. So that is packet capture, and as mentioned, you can do packet capture for hosts, and you can do it for devices. With a host or a device, it gets packets based on the IP address. Now, the other thing that I wanted to show you that I did is available from hosts. So I've implemented another service that is similar, and I'm going to move it over here and plunk it down in the corner. And by the way, I will be making this bigger when I go to show you the code, but I need to have a little bit of screen real estate, so it's probably best for you to be looking at this on your laptop or something with significant resolution here. Here you can see, this is my port scan thread. If you looked before over here on the left, this was my capture thread. So you can see right there, capture thread. This is my port scan, and it's waiting for requests on a port scan. So I can do 2 different types of port scan. The one that I can do is just a TCP port scan that will go out to the device, and it will attempt to retrieve information at a very high level. Just look for TCP open ports. And I'm actually going to click on this right now, and we'll see what happens. It pops up this dialog, and it actually went to this particular device it got a successful port scan and there were no TCP ports open for connectivity. Now that's an Amazon device that I have. If I tried this Google Home device, I can't remember what this does. Once again, it has no ports open for scanning. If I were to go to my other laptop, this Lenovo Yoga is actually a Windows laptop. If I was to run this, then it's actually going to end up failing. And the reason that it fails, for some reason, and I'm not sure why, but I need to be running in privileged or super user mode in order for this to succeed. So I can get a whole lot more information if I do run in a more privileged mode. So if I have this set up right, I haven't actually looked at this in a little while, but if I do have it set up right, then what I should be able to do is do this extended port scan. And if you look down here, you should see that I will get a request and I'll go out and begin to do that scan. Now when it pops this up, it does tell you, you can see down here that I did get this. It's going to do port scan on Lenovo Yoga Home. I am using Nmap, and these are parameters that I'm using. So I'm scanning for a maximum of, 5 minutes, because sometimes the port scans take a very long time. Now, depending on the device up, you can see this changed down here. And lo and behold, I have my port scan, my extended port scan information available to me. And these are the results. This is the Nmap request that I made. The command line for Nmap that it ended up using was this. It's going to this particular device, which is in my local network. It used TCP to do the scanning of ports 1 through 1024. It took 23.5 seconds. Basically, here are my scan results. So it scanned the addresses and it found that this is the IP address. Of course, that was the address that it went to, so that's clear. It did find the MAC address for that device. It found the host names for the device, so it got this from DNS. It attempts to match the operating system for the device. So this is actually running Windows 10, and it says with 87% accuracy, it's going to say it's Microsoft XP SP2, which I'm not sure what the internals of Microsoft are. If Windows 10 is probably built on XP, I'm sure what service pack it might be. This accuracy of 85 says it's Windows 7. 85, it says Windows Server, and that's it. So you can be pretty sure that it's a Microsoft Windows system, but it didn't tell for sure whether it was actually Windows 10, and I've seen that on a couple of devices. Now it's giving me some information, some of this Nmap information, I'm not exactly sure. It does say that the status of this device is up, and now it's listing me the open ports. So I can see that port 135 of TCP is open. That's an MSRPC port. That's a typical Microsoft port that it opens on Windows machines. 139 is another one of those. It's for doing Microsoft's SSN, whatever that might be. It's some type of NetBIOS communication. And port 445, which is Microsoft DS. Again, I don't know exactly what that is, but my Windows system has all the other ports closed except for that particular one. And it comes down here and says the vendor, well, yeah, apparently it's using it based just on this MAC address, and that MAC address is an Intel MAC address, so it says Intel corporate. Not sure exactly what the corporate means, but Intel probably means that this MAC address is from the MAC address class that has been assigned to Intel Corporation. So I can do this for other devices. A little bit more interesting, I can go to my home router. Let me go to my next page. This is my actual gateway. I'm going to go ahead and get this extended scan started, and then I'll let it finish. Okay, we're back. I suspect that I sped it up when I do the final editing so that you didn't have to wait, but the elapsed time for that scan, as you can see, Took 144 seconds, so that's over 2 minutes to do this scan. Now, here's the OS match. It has 100% accuracy that it's some version of Linux that it's running. That's probably true. A lot of the devices that you get are just Linux devices that are actually running wireless router code. It's running Linux as a base. At Tabulate Networks, we use Linux as a base for our wireless and SD-WAN solutions. So here's telling me the ports it used to do its scanning, and here are the ports that were open. So port 53, as you can see, that's a DNS port, is open, and the way that it found it was doing this particular type of mechanism, this test. Port 80 is open, that's an HTTP port. Port 111, which is RPC bind, I don't know what they're using that for. And port 443, that of course is HTTPS. Now it also was able to get information about the time that that device was last booted, which was way back in August. So we had to reboot our laptop a couple of times during, I think, the month of August. I'm not sure why, but we had to boot it up. And then this MAC address indicates that the device probably came from Eris Group, and I suspect that may be true. I know I've actually done an SDN class for Eris back in Atlanta, so I think that they do this type of equipment. Anyway, that's a general overview of what Quokka stuff I've been working on, and so yeah, hopefully that's interesting to you. I'm going to take a minute now and get things set up, and then we'll talk about printing. Okay, folks, so let's do the lesson part of today's session. As I mentioned, we're going to talk about printing. If you recall, we've gone through devices, functions, where we learned how to make Python functions and define them and call them. Modules, separating those functions into separate modules. We spent a fair amount of time on strings. Now we're going to talk a little bit about printing. Now, if you've been through the other sessions before, then you know we've already done a lot of printing, and so we're going to rehash that a little bit, and I'll show you a few new things, but there won't be a lot that's different in this particular class. But let's look at the code here and see if we can figure out what's going to happen. So the very first thing I'm going to do is I'm going to create a bunch of devices. Notice create devices. Where does that come from? Well, I have an import statement here. I defined in L3 functions, that's this thing right here, a function called create devices, and that's where I create some number of devices. And here I'm going to be creating 25 of them and storing them in a variable called devices. So I'll get a list of devices. And then I'm just going to print it out, and we'll see what that looks like. Obviously, this isn't going to look terribly good or easy to read. It's just going to print it out in one long line. Then we're going to look at using pretty print, which is very common for printing out data. I'm using that in Quokka to print out some of the scanning and capture data that I get. So we're just going to call pretty print on devices and see what that looks like in comparison. Then I'm going to manually go through a loop by myself. I'm going to go through devices, and for every device, I'm just going to have a pause in here. I'm going to create a new field within this dictionary. It will be called last heard, and I'm going to set it to the time at this particular time, and then I'm going to print it. After I do that, I'm going to do the same thing, but instead of building my own loop and printing stuff out, I'm going to use Tabulate, which, as we've seen in earlier sessions, simplifies the printing of stuff. It does a lot of the heavy lifting for you. Then I'm going to go through and basically do what Tabulate does, but I'm going to do it by myself by iterating through all of the devices again, and I'm going to use this F string in order to print out the data. So an F string is just like a regular Python string. So this is printing. It's a single print statement. It has, my formatting has put it on a different line just for readability, and the single string you can see right here, it actually goes a little bit longer. Let me make this a little bit smaller so that you can see it. So it actually is this entire string, and remember with an F string, the nice thing about it is I can put these curly brackets and put a variable name. And in this case, I'm using my dictionary variable, and I'm referencing the item, which has a key called name for that particular one, and I'm printing it out. Remember, we looked over, or maybe we haven't, looked at different ways to print things out. I think that we have, but we haven't really dwelled on it. Here I'm saying use 7 characters to print this out, and I want you to right justify it. That's that greater than sign. And for vendor, I'm using 10 characters to print it out. For device OS, look, I'm left justifying this one, and I'm using only 6 characters. And for the IP address, I'm using 15 characters, and I'm left justifying it. And for the last heard, I'm actually going to just use the string minus the last 4 characters. Now, last heard is going to have the actual date and the time, and then it has a dot and then fractions of a second. And I believe that there are 6 of those 6 different spots of resolution that it puts, and we're going to get rid of the rightmost 4 so that it only prints 2 of those. And here we're just going to sort it, and then we are going to show you how to do multiple print statements. I'll go into that in a minute. And now we're going to use an input statement which both prints something out and then gathers input. So without further ado, let's actually run this. I'm actually in the process of running it, so let me stop it. Now I'm going to run it, and you can see stuff is printing out here. While it's still doing that, let's go to the top and remind ourselves what's the first thing that we're doing. We're just using a print statement. This is what it looks like. So it looks like this. It doesn't end there. If I was to scroll this screen to the right, you can see there's 25 different devices in there, but it would be hard for a human to be able to read that, obviously. Now the next one, I'm using pretty print, and all I need to do is say pretty print devices, and look at how nicely it formats things for me. Here I see a square brackets, that means there's a list. Here's a curly bracket, that means it's a dictionary. And my dictionary is listed right here. And I can see that I have an item with a key called IP, one called name, one called OS, one called vendor, and one called version. And then it repeats that for every single device. So this is a handy way that is moderately human readable. It's not as easy as a table, but at least it's readable. And you can see I got down here, this is actually the 25th device that I've created, so it printed those out. The next thing I'm going to do is I'm using this loop where I go through here, and I'm actually sleeping with each one. The reason that I'm sleeping for 1/10 of a second is because I want my date time, my last heard variable, to be actually different for all of these. So here I'm going to make this a little bit bigger so that we can see it. We're going to print this out, and as you can see, over here, this is my last heard thing that I've created. And when we print this out in the table, you'll see that all of my last heards, this fractional part, are a little bit different. And that's because I put that sleep statement in there in order to cause me not to have the same value for that. Then I printed it out using Tabulate. Now Tabulate, remember, we're going to pass in both the list of things that we want printed, and we're going to specify, let me move this here. We're going to specify headers equals keys. That means I want you, Mr. or Ms. Tabulate, to print this out and use the keys for each dictionary, which is an item within the list, as the table, the headings for each of these columns. So remember, I have the name of the device, the vendor of the device, the OS, the version, the IP address, and the last heard. And you can see that I'm actually going to be printing these out with my Tabulate, and that I'm sorting it. And I'm sorting it by vendor first, then by OS, then by version. So when I look through this, I can see all of my aristas are together. It gets more interesting when I get down to Cisco because I have different OSs in Cisco. I have iOS, iOS XE, a couple of iOS XRs, and then within them I have, so for these 2 iOSs, you can see, well, this isn't actually going to be different, so they don't have to be sorted. Well, yeah, there's 3 iOS ones. We can see this, and so it's sorted by vendor, by OS, and then by version. And you can see that 15E comes after the 12.2 SE versions, etc. So that's what I did using our Tabulate. The next I do is I go through and I use this loop, and I'm using f-string. So here I'm actually printing things out. You have to spend some time with Tabulate. I didn't have to do this. I have to do this by hand. Let's look at vendor and OS. You can see compared to the dashed lines separating the title of the column and the actual values, I've got this one right justified and this OS left justified. And remember, that reflects what I have here. Vendor is right justified and OS is less justified. Let's go and take a look at what it actually looks like. So what I've done here, you can see that my vendor is right justified, my OS is left justified. And then these other ones, IP address was left justified. And then last heard, remember, this last heard value that I'm looking at up here has 4 digits worth of precision in the fractional part of the last heard. Here, however, I'm just printing 2 of those. So if you recall when we were looking at that over here on the far right, this is where I did string slicing. So if you recall from when we were looking at strings, which is what we did before this, we talked about how you can actually slice strings, and this gives me everything. I start, whatever's on the left-hand side of the colon is the beginning point because I don't specify anything. It's going to begin at the very beginning of the string, and after the colon, it's going to do the ending point. And here, because I say -4, it's going to take the very end -4 spots. And so what you see I've done is I've actually just truncated the last 4 of these because I don't really care about them all that much. All right, so that is using the loop and f-string. Here I'm just going to be sorting it by last heard. Let's see what that actually looks like. Can't actually remember. So here you can see, because I was waiting a little amount of time in between creating these things, like 1/10 of a second, you can see, if you recall, if you're wondering what I'm talking about, when I actually added the last heard to each of the devices, I created that item within the device dictionary by sleeping in between doing that every time. So here you can see 144604.42, 144604.32.22. You can see each of these has waited basically 1/10 of a second. And as you can see, I don't know if I did. No, I'm actually printing them out in the opposite order from the order in which they were created. So I'm actually sorting this. I've specified reverse equals true. So I'm specifying that I want to sort based on last heard. And I'm going to specify, pass in this item to sorted, which says reverse equals true. So it's going to sort it in the opposite order. And that's why over here, you see that these are in descending order. Now, multiple print statements, same line. What's that all talking about? Basically, it's this. Here I have a print statement. You'll notice every print statement that I have, it basically does a new line at the end of it. But here, I'm going to print data, and then I want it to stay on the same line. So I'm going to print out the device's name, and then I'm going to print out ... and then I'm going to say end equals ... That basically is the secret signal to Python to not print a carriage return line feed. And so what it will do is it will print this out first, and then it will sleep for some amount of time, and then it will print done. So let's watch this run actually, because it gets a little bit interesting. Here I'm creating all of those things. Here's what we're interested in. See, it's waiting some amount of time. It prints out the thing with the ... and then it does done. So I've done something in between the printing of the first print statement and the second print statement, and you can see that it's all gotten printed on the same line. Now the last thing that I'm going to do is this, and this isn't really printing per se, but this is actually going to be taking input from the command line. So here I'm going to actually run nmap and do the port scanner, and what I'm going to do is I'm going to allow the user, that would be me, to type in an IP address on my network, and then I will scan to see what's going on with it. So let me type this IP address in. Okay, I've printed that in. Nmap is going to do the scan, and now it's printed out the data. And notice I am in this loop that says while true. And so I'm going to cycle through this loop forever, or until I don't enter in anything and I just hit carriage return. So I'm going to do another one, 192.168.254.14. Okay, so now I've done another one, 192.168.254.14. I'm going to do the scan on that, and it's going to print out it didn't actually get any information of any use. So that's basically, we're not going to go into nmap right now. We'll do that in the networking section, but that's basically how you use input over here. Now, what I've done is I said if IP is either empty or none, I'm going to quit, and so I'm going to hit return here, and my process is done. So that is printing. You can do a whole lot with the things that I've shown you. You can generate some nice looking reports. You can either do them yourself using loops, or you can use something like Tabulate and just have it print things out for you. You can sort things before you do that. You've seen me sort devices on vendor, OS, and version. You've also seen me sort them based on last heard, and in that case when I did it, I reversed the order. So a lot of good things that you can do with printing in Python. Python makes it very easy to print stuff out. You can even just do the simple, if you're really lazy, do pretty print, and it actually comes out with a halfway decent thing. If you've only got a small number of things that you're looking at, you can certainly use pretty print. If you have something more than that, and especially if you want to please your boss or something like that, then you'll want to use Tabulate or generate your own form of doing that.